Tonight, I want to tell you about the farthest any human being has ever been from home. It is not the story you expect. There was no flag, no speech, no celebration. The record was set by accident, in the middle of the night, by 3 freezing men in a broken spaceship who were trying very hard not to die. It was April of 1970. Apollo 13 was 2 days into its flight to the moon when an oxygen tank exploded and turned a lunar landing into a rescue mission. The crew shut down almost everything to save power. The cabin went dark and cold. Cold enough that the walls sweated and the astronauts could see their own breath. And because the fastest way home was not to turn around, but to keep going. To swing around the moon and let its gravity throw them back toward Earth. Their crippled ship looped behind the far side of the moon on a path slightly higher than any crew had ever flown. For a few quiet minutes, Jim Lovell, Jack Swigert, and Fred Hayes were farther from Earth than any members of our species have ever been, before them or since. Here is the number. Just under 250,000 miles. It sounds enormous. Now let me translate it the way we will be translating everything tonight. Light, the fastest thing the universe allows, crosses that distance in about 1.5 seconds. 1.5 light seconds. That is the record. That is the high water mark of the human species. Every explorer who ever lived. Every empire. Every migration. Every voyage in 100,000 years of restless wandering fits inside a bubble that light escapes before you can finish, saying the words, light escapes. The record is now more than half a century old. Nobody has come close to breaking it. Most people alive today were born after it was set. Hold on to that number. 1.5 light seconds. Carry it with you tonight, because at the very end of our journey, we are going to need it. Because tonight, we are asking one of the oldest questions there is, and we are going to answer it properly, all the way down. How far can humans travel in the universe? Not in a movie, not in a daydream, in this universe, with its actual rules, which do not bend for us. Is the answer the moon? Mars, the nearest star, the far side of our galaxy? Or is there, written into physics itself, a line somewhere out in the dark, a border past which no human being, no matter how brilliant or patient or determined, can ever go? I will tell you now, there is an answer, and it shocked me. The edge of the map is real, and it is not where you think it is. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Now, let's begin. One warning before we set out. The question in our title is going to change shape on us tonight, and I want you to watch for it. How far can humans travel? That word, humans, looks solid right now. It will not stay solid. We are going to ask this question 3 different times before the night is over, in 3 different ways. Can a single living person make the journey and step out at the far end? If not, can a civilization make it, even if no single traveller survives the crossing? And if even that fails, can anything that carries our story make it? Anything at all that could stand on some distant world and honestly say, I came from Earth? 3 questions, nested inside each other like hulls of a ship. Tonight we will find out how many of them survive the voyage. And I want to be fair to those 3 men in the freezing capsule, because there is a detail from that night in 1970 that I am deliberately holding back. Something they did behind the moon. At the very moment they set the record, I will tell you at the end of the night, when you have seen the whole map, because it means more once you know how the story goes. For now, all you need is the picture, the most travelled species this planet has ever produced. The species that walked out of Africa and crossed oceans in canoes and put footprints on another world, has never been farther from its front door than light travels in the time it takes to blink twice. So that is where we stand, the front porch, and the question is how far the road goes. The honest way to find out is to walk it, one stretch at a time, and see what tries to stop us. So we will start tonight the way every journey starts, at the front gate, with the neighbourhood we already know, the sun and its family of worlds, our own backyard. It should be the easy part. It is not, because the first thing the universe wants you to understand about travel is the size of the yard. And the second thing, the thing almost nobody warns you about, is that the front gate is on fire. In August of 2012, in a room at the Jet Propulsion Laboratory in Pasadena, California, a group of engineers was listening to a spacecraft older than most of their careers. Some of them had worked on it as young men and women with dark hair and new degrees, and they had grey hair now, and the spacecraft was still out there, still talking, its voice grown so faint that the great dish antennas of the Deep Space Network had to strain to hear it. A whisper of a signal 20 billion watts weaker than a wristwatch battery by the time it reached Earth. The spacecraft was Voyager 1. It had been flying without a single day off since 1977, and that summer, the data coming down began to change. The particle counts shifted, the magnetic readings turned, slowly, carefully, over months of checking and rechecking. The team came to an extraordinary conclusion. Their machine had crossed the boundary where the sun's wind gives way to the thin gas between the stars. A thing built by human hands had left the sun's bubble and slipped into interstellar space. The farthest traveller our species has ever launched had finally reached the hull of the ship we are all sailing on. Bolted to its side, Voyager carries a golden record, a real phonograph record, plated in gold, with a needle and printed instructions for playing it. On that record there is thunder, and rain, and the sound of surf rolling onto a shore. There are greetings in dozens of human languages, and the cry of a newborn baby, and 1 hour of the recorded heartbeat and brainwaves of a young woman who, days before the recording, had fallen in love with the man leading the project. She has said she was thinking about him while the electrodes listened. So somewhere out there in the dark, right now, there is a love letter written in heartbeats, sailing between the stars. Remember that record. It is going to come back tonight, near the end, and it will mean something different by then. Now here is the part that reframes everything. Voyager 1 is the fastest thing we have ever thrown out of the solar system, moving at roughly 38,000 miles per hour, and it has been running flat out for nearly half a century. So how far has all that heroic flying actually taken it? About 23 light hours from home. Not light years, light hours. The distance light covers between breakfast and breakfast, 47 years of flight. And a radio message from Earth still catches up to Voyager in less than a day. Our champion, our record holder, our farthest machine, has travelled a distance the universe considers a rounding error. Let me put it on the model this channel has used before. Shrink the sun down to a basketball sitting in the middle of a field. On that scale, the Earth is a grain of sand about 90 feet away. Neptune, the outermost planet, is a slightly smaller grain, almost half a mile out. Voyager 1, after 47 years of continuous flight, has made it roughly 3 miles from the basketball, a long afternoon walk, and the nearest star, the next basketball over, is more than 4,000 miles away. On another continent, across an ocean, our fastest machine, in 50 years, has walked to the edge of the parking lot, and the journey we are asking about tonight crosses the Atlantic. And it gets stranger, because our solar system does not end at the planets. For past Neptune, the sun holds a vast shell of frozen debris, trillions of comets in cold storage, stretching an enormous distance out into the dark. We devoted a whole night on this channel to that place, the Oort cloud. So tonight, I will give you just the one number that matters. Voyager 1, at 38,000 miles per hour, will not reach the inner edge of that shell for about 300 years, and it will still be passing through it 30,000 years from now. Our own backyard, the part of space that legally belongs to the Sun, is so deep that our fastest machine will spend longer crossing it than human civilization has existed. The Roman Empire will have been dead for 32,000 years before our little probe with its golden record clears the fence line of home. Maybe you are thinking, fine, but Voyager is old. 1970s technology. A museum piece that happens to still be flying. Surely we have something faster now. We do. The fastest human-made object in history is the Parker Solar Probe, and in its closest passes around the Sun, it has hit about 430,000 miles per hour. That is genuinely astonishing. It is New York to Tokyo in under a minute, and I have to be honest with you about two things. First, Parker only reaches that speed by falling, diving deep into the Sun's gravity like a stone dropped down a well, and no ship bound for the stars gets to borrow that trick for the whole trip. But second, let us be generous. Suppose we could somehow hold that speed, the best speed our species has ever touched, in a straight line toward the nearest star, 430,000 miles per hour. No slowing, no stopping. The trip would take about 6,500 years. 6,500 years. At our absolute record pace, the pace we achieved exactly once, by cheating, with a probe the size of a small car, the journey to the very nearest star lasts longer than recorded history. The pyramids at Giza are not yet 5,000 years old. A crew departing at Parker speed today would arrive with the entire span of Egypt, Rome, and every nation on the modern map fitting inside their travel time, with centuries left over, and at Voyager's more honest speed, the number swells past 70,000 years. That is not a voyage. That is an ice age. So this is what the backyard teaches us. And it is the first hard lesson of the night. The problem is not that we are slow, by every standard our species has ever known. These machines are magnificently, absurdly fast. The problem is that the universe is built on a scale that makes our best speed look like standing still. Distance is the first wall, and it is taller than it has any right to be. But distance, it turns out, is not even the wall that worries the people who plan these missions. Ask the engineers and the flight surgeons what actually keeps them up at night, and they will not talk about miles. They will talk about the cargo, because before we say another word about engines, we have to face something uncomfortable about the passenger. The passenger is you, and you were built, bone by bone, cell by cell, for exactly one world. On the first night of March, 2016, a capsule fell out of the sky over the frozen grasslands of Kazakhstan, glowing like a struck match, and inside it was an American astronaut named Scott Kelly, coming home from the longest single spaceflight any NASA astronaut had ever flown. 340 days aboard the International Space Station, nearly a full year off the planet. When the hatch opened, the recovery crews reached in and lifted him out. And I want you to notice that word, lifted. He did not climb out. The men who go to space ride home in other people's arms. In the weeks that followed, doctors catalogued what a year of weightlessness had done to a healthy, superbly conditioned human being. He came back temporarily taller, because his spine had stretched without gravity to compress it. His bones had been quietly dissolving, his skeleton shedding calcium month after month, because the body, sensing no weight to carry, had decided the frame was a luxury. The fluid in his body had drifted upward for a year, puffing his face and pressing on the back of his eyes until the eyeballs themselves changed shape. part of a syndrome that has permanently altered the vision of astronauts before him. His heart, with so little work to do, had softened toward the shape of a couch potato's heart inside the chest of an athlete, and Scott Kelly had an identical twin brother, Mark, a fellow astronaut who spent that year on the ground, which handed science a once-in-a-lifetime controlled experiment. When researchers compared the brothers afterward, they found that the very expression of Scott's genes had shifted in orbit, thousands of them dialing up and down, some of them still behaving differently months after he landed. His own body, down at the level of its instructions, had started rewriting itself for somewhere else. And here is the detail that should stop you. All of that happened 250 miles from home, close enough that Kelly could see his house from the window, close enough to text his family, watch the Super Bowl, and come home in 3.5 hours if something went wrong. He never even left the shelter of Earth's magnetic field, the invisible umbrella that shields the station from the worst of what space carries. 1 year, in the shallow end of the pool, holding the ladder, and it rearranged his eyes, his boners, his blood, and his genes. Now let me tell you about the deep end. Beyond that magnetic umbrella, space is not empty. It is raining. A thin, endless drizzle of galactic cosmic rays. Atomic nuclei blasted out of dying stars millions of years ago and accelerated to nearly the speed of light. Most are single protons, but some are the naked cores of heavy atoms, iron stripped of its electrons. And these are the ones the flight surgeons lose sleep over. When a heavy ion passes through a human body, it does not tap politely. It drills, snapping DNA on its way through like a bullet passing through a library, leaving a track of shattered molecules behind it. On Earth, you are shielded by the planet's field and by 70 miles of air. On the station, astronauts are partly shielded and still absorb far more than any radiation worker on the ground. On the open road to Mars, there is no umbrella at all. NASA's own studies estimate that a single round trip to Mars would expend most of the radiation exposure an astronaut is permitted in an entire career, and would raise their lifetime cancer risk by a margin that medical review boards are still arguing about. Every 3 days on that voyage, on average, a heavy galactic nucleus passes through some part of your brain, and the radiation is only one line on the chart. NASA formally tracks 5 great hazards of deep space travel: radiation, altered gravity, isolation and confinement, a hostile, sealed environment where the machines keeping you alive are also your only walls, and distance from Earth itself. The simple, brutal fact that past a certain point, no rescue is coming and no conversation is possible. Here is the pattern hiding in that list. And it is the point of this whole chapter. Every single one of those 5 hazards gets worse with distance. Every mile you add turns the dial up on all 5 at once. The universe does not just make the journey long, it makes the traveller sicker the farther he goes. I want to be fair to the human body, because it is a masterpiece. It is the finest machine 4 billion years of evolution ever tuned. But it was tuned to one specification sheet, one gravity. Exactly. One magnetic shield of one particular strength, 1 day length, one air mixture, one narrow band of temperature. All of it the signature of one specific planet. We are not general-purpose creatures who happen to live on Earth. We are Earth, walking, down to the calcium in our bones and the rhythm of our sleep. We are the local conditions of one world, folded up and set in motion. Take the machine off the only test bench it was ever calibrated on, and it begins, gently and immediately, to come apart. So look at what has happened to our 3 nested questions. Only 1 chapter into the walk. The first question, the strictest one, asked whether a single living human can make the journey and step out healthy at the far end. We have not even reached Mars, the next door neighbour. 3 light minutes away, and that question is already bleeding. Not dead. Engineers are fighting for it with shielding designs and spinning habitats and drug trials. And it is a fight we may yet win at the scale of the solar system. But it is a fight, and the arena is only our own front yard. And yet, if you ask me tonight what actually stands between humanity and the stars, I would not start with the body. The body is the problem money and cleverness might solve. There is another problem, older and colder, that does not care about cleverness at all. It is a single line of mathematics, and it was written down more than a century ago by a man the world had decided was nobody, a half-deaf schoolteacher in the Russian countryside, who never launched so much as a bottle rocket, and who worked out, alone, with a pen, the one equation every rocket ever built must obey. That equation has a nickname among the people whose careers it rules. They call it the Tyranny. Picture a wooden house on the edge of a small Russian town called Kaluga, 100 miles and a whole world away from Moscow. In the 1890s, inside, a schoolteacher is working by lamplight, surrounded by hand-built models, tin cones and wired contraptions his neighbours consider proof of a gentle madness. His name is Konstantin Tsiolkovsky. Scarlet fever took most of his hearing when he was 10 years old, and with it, his childhood, shut out of school, shut out of easy friendship. He taught himself out of library books, physics, mathematics, astronomy, all of it filtered through a silence that never lifted. He grew up to teach arithmetic to schoolchildren in the provinces, and at night, in that wooden house, the deaf man asked himself a question almost nobody on earth was seriously asking. What would it take, exactly, to leave this planet? Not in a story. He had read the stories, the cannons to the moon, and he checked the arithmetic and found they would flatten their passengers into paste. Tsiolkovsky wanted the real number, and in 1903, the same year, the Wright brothers coaxed their machine off the sand for 12 seconds. He published it. One compact equation relating 3 things: how fast your engine throws its exhaust, what fraction of your ship is fuel, and how much speed you get in return. Every rocket that has ever flown, from the earliest firecrackers to the machines SpaceX lands on barges, obeys that equation without exception. It is the law of the road for the entire universe, and a man who could barely hear the world was the first to write it down. So, what does the law say? On the surface, something obvious: to go faster, carry more fuel. But inside that obvious statement, a trap is waiting, and the trap is the whole story of why the stars are hard. The fuel you carry has weight, so the fuel you burn at the start of the flight is spent lifting the fuel you will burn later. Which means if you want to burn more fuel later, you need extra fuel earlier to haul it, and extra fuel before that to haul the extra. And the ship swells, and swells, and the arithmetic feeds on itself. Speed grows gently, arithmetically, plodding step by step. The fuel bill grows exponentially, doubling and redoubling. A curve that starts as a slope and turns, with terrifying speed, into a wall. You have seen this wall with your own eyes. By the way, it is the reason rockets look the way they do. Consider the Saturn V, the machine that carried men to the moon. Still the most beautiful brute force object our species has produced. On the launch pad it stood taller than a football field, is long and weighed about 3,000 tons. Ask yourself how much of that returned. The answer is the small charred cone at the very top. The crew capsule, around 6 tons. Roughly the weight of a delivery truck. Everything else, the gleaming white tower, the 5 great engines, the tanks, the stages, all of it existed to be thrown away in flight. 99.8% of the vehicle sacrificed to push the remaining fraction of 1% to the moon and back. That is not a design choice. That is the equation, standing in the daylight where everyone can see it. And the moon, remember, is 1.5 light seconds away. So the obvious question is what the equation says about a star. Take the nearest one, 4.25 light years out, and be modest. Ask for a ship that gets there in a few decades, a meaningful fraction of light speed, burning the best chemical fuel we have, the same hydrogen and oxygen that flew Apollo. Run the numbers. And the equation does not tell you the mission is expensive. It tells you the mission is not allowed. To push even a single small capsule to 1/10 of light speed on chemistry, the mathematics demands more fuel than there is matter in the visible universe. Read that again. You could feed every star, every planet, every galaxy we can see into the tanks. And the equation would look at you and ask if there is any more. The tyranny is not that the trip costs too much. The tyranny is that past a certain ambition, chemistry stops taking your money entirely. This is the point in the night where the whole problem snaps into focus. A journey has 3 parts, and we have now met all 3. The distance, which is measured in tens of thousands of years at our best speeds. The traveller, a soft, radiation-soaked machine calibrated for exactly 1 planet. And the price of speed itself, which climbs an exponential wall the moment you ask for more than the neighbourhood. Any one of these would be a serious problem. All 3 together are a verdict. And the verdict of Act 1 is this. With the bodies we have and the fire we know how to burn, the human species is locked inside its own solar system. The front yard is the property line. Chemistry has carried us as far as chemistry goes. Tsiolkovsky knew it. 2. He never believed his own beloved chemical rockets were the final answer. Only the first rung. And he left behind a sentence that has outlived everything else he wrote. A sentence you have probably heard without knowing whose it was. Earth is the cradle of humanity. He wrote, but one cannot live in a cradle forever. I find it worth pausing on who said that. Not a conqueror. Not a billionaire. Not an agency with a budget. A man locked since childhood inside his own silence, who looked up at night from a town nobody visited and decided the whole species was in the same position he was. Sealed in, but not staying. So the cradle is sealed by an equation. Fine. Then the way out is to stop burning chemicals and find a fire the equation respects. Something thousands of times more violent than anything Apollo ever lit. And here the story takes a turn I promise you is real. Because in the summer of 1958, in a quiet office in San Diego, California, a small team of physicists, some of the finest minds of their century, sat down and designed exactly that ship. Their plan for reaching the planets and eventually the stars was not a metaphor and not a cartoon. They intended to build a ship the size of an office building, load it with 2,000 atomic bombs, and ride the explosions. And the strangest part of the story is this. It would have worked. The project was called Orion, and it remains one of the strangest true stories of the 20th century. In 1958, at a company called General Atomics in San Diego, a small team of physicists began designing a spacecraft that would be propelled by atomic bombs. I want to be precise here, because it sounds like a joke, and it was never a joke. The plan was to build a ship the size of a 16-story building, hang a massive steel plate off the back of it on giant shock absorbers, and then, once the ship was moving, drop small nuclear bombs out behind it, one at a time, and detonate them. Each blast would slam into the plate and shove the ship forward. Then you drop another bomb, and another, 1,000 of them, 2,000. You do not burn fuel in a chamber. You ride a chain of controlled apocalypses across the solar system. The men who worked on it were not cranks. One of them was Freeman Dyson, one of the great physicists of his generation, and he believed in Orion so completely that he planned to go himself. The team had a slogan that tells you everything about the era. Saturn by 1970. They meant it. They ran the numbers over and over, and the numbers kept saying yes. They even built a small working model, propelled by ordinary explosives, and flew it a few hundred feet into the California sky to prove the rhythm of blast and recovery could actually be ridden. The physics was sound. The materials existed. Of all the Starship concepts humanity has ever drawn, Orion holds a lonely distinction. It is the one we could have started building in the 1960s. And, on paper, Amateur Orion, scaled up and refined, could reach a few % of the speed of light. Suddenly, the nearest star is not 70,000 years away. It is a few centuries away, still unthinkably far. But watch what just happened. One idea. One terrible, magnificent idea. And the travel time to another star fell by a factor of 200. For the first time tonight, the wall moved. So why are we not living in that future? 2 reasons, and they are worth hearing, because they will echo through this whole chapter. The first is that in 1963, the Nuclear Test Ban Treaty made it illegal to detonate nuclear weapons in space, and Orion, which was nothing but detonations, died at the stroke of a pen. The second reason is deeper. To leave Earth, an Orion ship would have to ride its bombs up through the atmosphere, scattering radioactive fallout across the planet it was trying to leave. Dyson himself did the grim arithmetic on what each launch would statistically cost in human health. And the man who wanted to sail to Saturn on a pillar of atomic fire looked at his own numbers and stepped back. The ladder's first rung held our weight. We chose not to climb it. And honestly, the choice was probably right. But the idea did not die. It evolved. Through the 1970s, engineers and physicists asked the obvious next question. What if you replace the bombs with the fire of the stars themselves? Fusion, the process that powers the sun. Squeezing light atoms together until they fuse and release energy, far cleaner and far denser than any fission bomb. The British Interplanetary Society spent 5 years designing a fusion starship called Daedalus, a robotic probe the size of a battleship that would ignite tiny fusion pellets, 250 of them every second, and ride the glow to 12% of light speed. 12%. The nearest stars in 50 years instead of 50 centuries. The design filled volumes. The physics held up. There was just one small item missing from the plan, and it is still missing today. We do not know how to build the engine, nearly 70 years after fusion research began. Humanity has yet to run a single power plant on it here on the ground. Standing still, with the full resources of civilization plugged into the wall, Daedalus asked for that unsolved miracle to be miniaturized, made flawless, and fired 250 times a second for years without a hiccup. In the dark, alone, with nobody aboard to fix it. So the climber reaches for the next rung. If fusion is hard, go all the way to the top. Antimatter. This is the perfect fuel. And I mean that as a literal statement of physics. When matter touches antimatter, both are annihilated completely. 100% of their mass converted to pure energy by the most famous equation ever written. Pound for pound. Nothing in this universe releases more. An antimatter rocket is the theoretical ceiling. The best engine the laws of nature permit you to build out of fuel and thrust. And here is what that perfect fuel costs. Antimatter barely exists in our universe. Every particle of it must be manufactured, one at a time, in the great accelerators, at fantastic expense of energy. And our entire species, running its finest machines flat out, produces roughly 1/1000th of a gram per year. A starship needs tons. At current production rates, fueling one ship would take longer than the age of the universe. And storing that fuel means suspending it in magnetic fields where it can never, ever not once in decades, touch the walls of its own tank. The perfect fuel is perfect in the way a mountain of solid gold on the moon is perfect. Real, magnificent, and not coming down to us. Which brings us to the last rung on the ladder. And this one is different, because this one is being funded, right now, by real money. In 2016, a project called Breakthrough Starshot was announced, backed by $100 million and endorsed by Stephen Hawking in one of his final public campaigns. Starshot looked at everything we have discussed tonight. The tyranny of fuel, the impossible engines, and made a move of genuine genius. It threw the engine away. It threw the fuel away. It threw almost everything away. The Starship becomes a chip the size of a postage stamp, weighing about a gram, attached to a light sail a few meters across, thinner than a soap bubble, and the engine stays home, a vast array of lasers on a mountaintop on Earth, firing in perfect unison, focuses 100 gigawatts of light onto that sail and shoves it. For a few screaming minutes, the little craft accelerates at thousands of gravities. And when the beam shuts off, the chip is coasting at 20% of the speed of light, Proxima Centauri in about 20 years, within some of our lifetimes, a machine built by human hands, carrying human photographs and human recordings, could be falling through the light of another sun. I want you to feel how remarkable that is. After a whole chapter of impossible engines, this one might actually fly. But now look at the fine print. Because the fine print is the whole reason our night does not end here. The passenger is a gram. The trick works precisely because the payload weighs less than a paperclip. Scale that sail up to carry a human being, with a seat, and air, and water, and walls, and the arithmetic detonates in your hands. The sail grows to hundreds of miles across. The laser array grows until it is drinking a large fraction of the electrical output of human civilization, holding perfect focus on a target thousands of miles away. For years, the trick that makes Starshot possible is the same trick that locks us out of it. We have finally found a door to the stars, and it is the size of a mail slot. Step back and look at the ladder we just climbed, because from a distance, it has a shape. Bombs we could build but dared not use. Fusion we would gladly use but cannot build. Antimatter, perfect and unobtainable. And a beam of light that can carry our machines but not our children. 4 rungs. And on every single one, the same quiet trade appeared. The faster the ride, the smaller the passenger. We spent an entire night on this channel aboard the giant generation ships that try to break that trade by brute force, and another night chasing the physics of faster-than-light travel. So you know those roads exist, and we will meet them again before morning. But the pattern stands, and it is Act 2's first hard truth. Speed, it turns out, is not really an engineering problem. It is a bargain. And the universe sets the exchange rate, and the rate is cruel. And yet, suppose we pay it. Suppose some future century, richer and cleverer than ours, builds the fusion engine, tames the antimatter, scales the sail, and a ship with human beings aboard actually leaves the harbour at a serious fraction of the speed of light. The hard part is over. Surely. Ahead lies nothing but open, empty ocean, 4 light years of the cleanest vacuum in nature, the gentlest, emptiest road in existence. I am sorry, that road is a lie, and to show you why, I need to introduce you to the smallest villain in the history of this channel. It has been drifting between the stars, minding its own business, for 4 billion years. It weighs less than a snowflake, and it is about to hit a starship. Out in the space between the stars, tonight, there is a grain of dust. It is smaller than the period at the end of a printed sentence. It was made before the Earth existed. Soot from a star that died so long ago The galaxy has turned 20 times since, and in 4 billion years of drifting, it has never touched anything larger than an atom. It has no motion worth mentioning. It is simply there, hanging in the dark, the way it has always been. It is the single most harmless object you can imagine. Now send a starship at it. At 20% of the speed of light, the mathematics of impact stops behaving the way anything in your experience behaves. Speed, when you double it, does not double the violence. The energy of a collision grows with the square of velocity. And at these velocities, the squares become monstrous, a harmless grain of dust. Meeting a ship at a fifth of light speed, strikes with the energy of a hand grenade. A particle you could not see with a magnifying glass hits like a weapon of war. Something the size of a grain of rice arrives like an artillery shell. And a pebble, an actual pebble, one lonely piece of gravel adrift in 4 light years of nothing, would reach deep into the ship and end the whole voyage. 400 years of civilization's effort. In a silent white flash, your first instinct is the pilot's instinct. Steer around them. And here the universe closes the exits with a kind of casual cruelty. You cannot steer around what you cannot see, and these things cannot be seen. A dark grain of dust reflects no light, no radar, no telescope, no instrument we can even sketch on paper detects a speck of soot at any useful distance, and even if some miracle sensor spotted it, do the arithmetic of the encounter. At a fifth of light speed, you are covering 37,000 miles every second. A warning that arrives a full second early is a warning that arrives with 37,000 miles already gone. There is no dodging, no braking, no flinching. Whatever sits on the line you drew across the galaxy, you are going to meet it. So you stop being a pilot and become an engineer. And you do what engineers have always done. You put armour on the front, a thick shield riding ahead of the ship, layers of ceramic and metal and ice, a sacrificial forehead that takes the hit so the crew does not have to. It genuinely helps. It is also a trap. And by now, 3 chapters deep into this night, I suspect you can smell it coming. Armour has mass. Mass must be accelerated. And waiting patiently underneath this entire conversation, arms folded, is the deaf schoolteacher's equation from Chapter 4, which never went away and never will. Every ton of shielding demands its mountain of extra fuel, and the mountain demands a bigger mountain to move itself, and the exponential wall we escaped through cleverness and lasers comes rising back out of the ground directly in our path. The universe, it turns out, taxes the defense as brutally as it taxed the speed. And the dust is only the villain you can point at. There is a second attacker on this road, and it is far stranger, because it is the road itself. The space between stars is not a perfect vacuum. Every cubic inch of it holds a scatter of hydrogen atoms, a few dozen of them, drifting loose. That is emptier than the best vacuum chamber on Earth. So thin it should not deserve a mention. At a walking pace, at a rocket's pace, it does not, but speed. Remember, changes what things are. Climb toward relativistic velocity, and those sparse, sleepy atoms transform. From the deck of the ship, the interstellar gas becomes a wind, and then a hail, and then something you would have to call a particle beam. Each drifting atom slams into the bow as a spike of hard radiation. The gentle fog between the stars, at 20% of light speed, becomes a continuous sleet of it pouring into the front of the vessel. 60 times denser at the bow than anything the ship would feel at rest. Gnawing the hull, cooking the forward compartments, SAT-SSPing away the leading edge of anything we build. Atom be atom. For decades without pause, nobody is shooting at the Starship. The Starship is impaling itself on the galaxy. There is even a third problem, quieter than the other two, and in some ways it is my favourite. Because it is so absurdly domestic. Heat. Everything aboard makes it. The engines, the reactors, the machines, the crew. Every warm body and running circuit pours out waste heat. And on Earth we barely think about this, because the planet carries it away, into the air, into the water, into the night. A starship is a sealed bottle, and space, for all its legendary cold, is the best insulator in nature. A vacuum with nothing to hand your heat to. The only way to shed warmth is to glow it away slowly from radiator panels. And if your radiators fall behind your reactors, the ship does not freeze in the dark like the movies promise. It cooks, gently, inevitably, from the inside, in its own trapped warmth, like a thermos of coffee that stays cruelly hot for a journey of 40 years. Step back with me now, because this chapter has quietly rewritten the problem we are solving, and I want to say the new version out loud. We spent all night until now believing the enemy was distance, that the space between stars was an empty ocean, and our only failing was a slow boat. Now watch the truth surface. The ocean itself fights back. The emptiness has teeth. The vacuum has weather. The road burns whoever runs on it. And the harder you run, the hotter it burns. Speed was supposed to be the answer to distance. Speed turns the universe hostile. That trade has no bottom, and no clever sentry will ever fully cancel it. Because it is not a flaw in our ships. It is the character of space itself at high velocity. And now, having armoured the bow and survived the sleet and shed the heat, having crossed 4 light years of hostile emptiness through decades of darkness, our battered, the magnificent ship approaches the light of another sun. The crew, or their children, gather at the windows. The destination planet swells from a point of light into a world. Which brings us to the question nobody in the movies ever asks. And it may be the most quietly devastating question of the entire night. The ship is travelling at 37,000 miles per second. How, exactly, do you stop? Let me paint you the greatest moment in the history of exploration. The year is 2060-something. 20 years ago, a laser array on a mountaintop fired a gram of humanity toward the nearest star. And tonight, the little probe arrives. Proxima Centauri swells out of the darkness. Its planet, Proxima b, the world we have wondered about for a century, rises ahead. An actual alien landscape, unseen by any eye since the universe began. The cameras wake. This is it. First contact between our species and another solar system. Now let me tell you how long the visit lasts. At 20% of the speed of light, the probe crosses the entire width of the planet in about 1/3 of a second. The whole encounter, the approach, the closest pass, the fading goodbye, is over in a matter of hours. And the useful part, the part where the planet is more than a dot, is minutes. 20 years of flight for a glance out the window of a bullet. A few precious, blurred photographs, radioed home across 4 light years. And then the probe is gone, past the star, out the far side of the system, falling forever into the dark with no way to slow, no way to turn, no way to ever visit anything again. Its journey does not end at Proxima. Its journey ends never. And here is the confession hiding inside that scene. Nothing went wrong. That flyby is the plan. It is the plan because of a truth so simple and so brutal that it gets left out of nearly every dream about the stars. Getting up to speed is only half the ticket. If you want to stay when you arrive, to orbit that new world, to land on it, to live, you have to shed every last mile per second you spent decades buying. Arrival is acceleration run backward. The entire mountain of energy climbed a second time. And the universe offers no discount for the return trip. Think about what that means for each ship we have met tonight. The laser sail cannot stop, because its engine is a mountaintop in another solar system, pointed the wrong way. 4 years of warning behind every command. The fusion ship, the antimatter ship, any ship that carries its own fire, must save half its burn for the far end. And that word, half, is one of the great lies of arithmetic, because the schoolteacher's equation does not charge you double for a round trip of velocity. Every pound of fuel reserved for braking is a pound of dead cargo during the entire acceleration, demanding its own fuel to push it, which demands more in turn. Ask a ship to both start and stop, and the exponential wall from Chapter 4 does not add. It multiplies. The fuel bill is not twice as tall. It is the tall bill squared. Engineers, bless them, have tried to cheat the toll, and the schemes are genuinely beautiful. A magnetic sail, a vast invisible loop of field cast ahead of the ship like a parachute, dragging against the thin plasma between the stars, letting the galaxy itself slow you down, or braking against the destination sun, unfurling a mirror and letting the pressure of its light push back against your fall. The physics is real, and the price, every time, is the same currency, time. These breaks are whispers. They work over decades, stretching a 50-year crossing toward a century, trading the mass of fuel for the years of a human life, paying Tsiolkovsky by handing the calendar to his collector. So look at where the road has led, because we have arrived somewhere important. And I want to stand here a moment. Add to night's ledger honestly. The distances are measured in light years. The speed to cross them in a lifetime turns dust into artillery and the vacuum into a blowtorch. And now we learn the journey must be paid twice. Once going and once stopping, at prices that multiply. Run every version of the mission through every engine on the ladder of fire. Keep only what known physics will actually sign, and the numbers converge, again and again, on the same quiet sentence. With everything we understand today, a voyage between stars, for human beings, takes centuries, and there it is. Do you remember the 3 questions from the beginning of the night, nested inside each other like the hulls of a ship? The first one, the strictest one, the one about a single living person stepping out under the light of another sun. That question has been wounded since Chapter 3, limping since Chapter 4. Tonight, at the edge of our own star system, with the physics we actually possess, whoever boards that ship in the harbour will be dust long before the harbour bell rings on the other shore. The traveller cannot survive the trip. That is the finding of Act 2, and no engine on the drawing boards of this century repeals it. But do not mistake a death for a defeat, because the engineers who reached this same wall did not turn back. They stood at it for a while, and then they proposed something that still takes my breath away, equal parts brilliant and terrifying. If the voyage is longer than a lifetime, they said, then a lifetime is the wrong unit. Do not send a traveller. Send the thing that outlives travellers. Send birth and death and birth again. Send a town. Load the ship with 1,000 people, and soil, and water, and seeds, and let the crossing be made not by a crew, but by a chain of generations. Each one born aboard, each one buried aboard, each one passing the mission to children who never chose it. The people who launch will not arrive. The people who arrive will know Earth the way you know ancient Rome. It solves everything, and what it costs, no equation can hold. Somewhere between the stars, aboard a cylinder of steel a few miles long, a girl is being born. It is the year 212 of the voyage. She arrives on the agricultural deck, under lamps that imitate a sun nobody aboard has ever seen, and her first cry drifts out over rice paddies curving up and away toward a horizon that bends the wrong direction. because her entire world is the inside of a rotating drum. She will grow up strong and curious. She will learn to swim in a river that flows in a perfect circle. And one day, the way every child aboard eventually does, she will ask her mother the question the ship has never once answered. Well, why are we in here? And her mother will give her the only honest answer that exists. Because a long time ago, on a world you will never see, your great-great-great-grandmother decided you would be. We spent an entire night on this channel aboard these ships, the generation ships, walking through the engineering deck by deck, the reactors, the farms, the failures, the mathematics of keeping a sealed world alive for centuries. If you want the machinery, that night is waiting for you. Tonight I only need you to carry 3 of its numbers. Because tonight we are not here for the machine. We are here for the girl. First number. A crew cannot be a dozen heroes. Genetics is unsentimental, and a population that's small folds in on itself within a few generations. The studies argue over the figure, but they live in the same neighbourhood. Hundreds of people at minimum, more likely a few thousand. Every one of them needing food, water, air, medicine, and a reason to get up in the morning. For centuries, with no resupply and no exit. Second number. Every attempt our species has ever made to build a sealed, self-feeding world has failed. And the most famous failure is the most instructive. In the early 1990s, 8 people sealed themselves inside Biosphere 2, a 3-acre glass ark in the Arizona desert, the most sophisticated, closed habitat ever constructed, with an entire planet of experts standing just outside the windows. Within 18 months, the oxygen was quietly vanishing into the concrete. The crops were faltering. Most of the pollinating insects had died while one species of ant conquered the ark. And the crew, hungry and gasping and heroic, had split into factions that reportedly stopped speaking to each other. 18 months. In Arizona, with the cavalry a phone call away, the Starship needs the same trick to run flawlessly for 500 years, in a place where the nearest help is measured in light years and generations. Third number, and it is the one that matters most tonight. On a 500-year crossing, something like 20 generations will live and die aboard. 20. And when you hold that number up to the light, you see the true cargo of a generation ship. And it is not the seeds or the reactors. It is a chain of human lives. And almost every link in that chain is a person we never talk about. Because we always tell this story from its endpoints. The brave founders who volunteer, who wave goodbye to Earth knowing what they are giving up. The lucky arrivals, 4 centuries later, who get to walk out under a new sun. But the ship is not made of endpoints. The ship is made of middles. Generation 8. Generation 11. The girl from the agricultural deck. She did not volunteer. And she will not arrive. Her whole existence. Birth. Childhood. Love. Work. Old age. Death. Happens in the corridor between a world she cannot remember and a world she cannot reach. Earth, to her, is a story her grandmother told. A blue circle in the archive footage. Half legend already. The destination is a dot in a telescope that will not grow noticeably brighter in her lifetime. She is a bridge. A living link whose entire purpose was decided at a funeral she never attended. For a dream she never dreamed. And the mission needs her to spend her one life maintaining the filters and raising the next link. And it needs her children to do the same. And their children, 20 times in a row, without one generation ever standing up and saying no. And that is precisely what history says they will do. Stand up and say no, because cultures do not hold still, not even in a can. Seal a town in steel for 5 centuries, and the language will drift until the founders' recordings need subtitles. Beliefs will mutate. The mission itself, so sacred at launch, becomes scripture, then becomes history, then becomes one faction's opinion, somewhere around generation 6 or 10. A generation will look around and notice that the ship is not a vehicle at all. It is simply the world, the only world, and it works fine, and the tomatoes are growing, and the river flows in its circle. Why exactly are we decelerating into the dangerous unknown? They will ask, on the orders of the dead. So here is what actually docks at that distant star, 4 or 5 centuries after a crowd on Earth wept at a launch. A vessel full of human beings. Absolutely, but not the humans who left. And I mean something deeper than the obvious. Different words in their mouths. Different gods. Different faces shaped by 20 generations of a closed gene pool. Different bodies raised in spun gravity and ship air. And a homeland. They know the way you know, Troy. Something from Earth arrives. Whether Earth arrives, whether we arrive, is a question I will let you argue about in the comments. And it is the second of our 3 nested questions beginning. Very quietly. To creak. The founders knew all of this. By the way, the people who design these missions on paper today know it too. 20 generations is the price. And the middle generations pay almost all of it. And the designers know it. And they keep designing. Because centuries of travel time leave no other door. Unless the travellers could do the one thing no crew has ever done. Skip the middle. Close their eyes above one star and open them above another. With the centuries gone like a single night, board the ship, and simply not be there for the voyage. Science fiction has had a word for that trick for 100 years. What you may not know is that medicine, in the last few years, in a handful of operating rooms in America, has started to have one too. There is a procedure being tested in trauma centres in the United States. Right now, in our lifetime, that would have been called witchcraft in any other century. It is reserved for the worst cases. The gunshot and stabbing victims who arrive with the heart minutes from empty. Patients the surgeons know they are about to lose. And it works like this. The team opens the great vessels, drains the patient's blood, and replaces it with ice-cold saline, chilling the body down and down until the heart stops entirely and the brain goes silent. No pulse, no breathing, no brain activity. By every definition medicine used for most of its history, the person on the table is gone, and they stay that way, suspended in the cold, while the surgeons work without a clock screaming at them. Then the repairs are finished, the warm blood returns, and the heart is restarted. The formal name is emergency preservation and resuscitation. The surgeons have a blunter way to describe it. They are learning to pause a human being. The pause lasts about an hour, and the moment you hear that, you can feel where this chapter wants to go, because the dream practically assembles itself. If medicine can switch a person off for an hour, then somewhere down this road is the Starship of every movie you have ever seen. Rows of quiet pods, frost on the glass, a crew sleeping through the centuries while the automated ship sails on, the middle generations from last chapter, the girl on the agricultural deck, the 20 links in the chain, all of it replaced by one crew who close their eyes in Earth orbit and open them under a new sun. No town, no drift. No one is asked to spend a life in the corridor. You skip the voyage entirely. I want that ship to be real. So let me be honest with you about the distance between that operating room and that starship. Because the distance is the story. An hour of cold pause is a miracle. And the gap between 1 hour and 1 century is not a gap you close with better refrigeration. It is a different problem hiding under the same word, held in deep cold for months. The body does not simply wait. Ice is a vandal. Water expands as it freezes, and crystals form inside cells and shred them from within, which is why nobody has ever been brought back from true freezing. and why the animals that survive winter frozen solid, the wood frogs, the Arctic insects, flood themselves with sugars and antifreeze and are, unhelpfully, not built anything like us. So perhaps you do not freeze, perhaps you merely chill, and slow the body the way hibernating bears slow. Torpid, cold, barely burning. Bears run that trick for 6 months. We need 600 years, and through every one of those years, the sleeper still ages, still absorbs the cosmic radiation sleeting through the hull from Chapter 3, still needs muscles and bones that dissolve without use, and still needs the one organ we understand least, the brain, to hold its wiring, its memories, itself. Through centuries of cold stillness, does the person who wakes at Proxima remember the person who lay down above Earth? Nobody on this planet knows. The honest status of suspended animation tonight is this: real medicine, working miracles, measured in hours. The Starship needs those same miracles measured in centuries. And between hours and centuries stand walls of biology nobody has yet found a door through. And it was at roughly this point in the conversation, staring at those walls, that some engineers and ethicists proposed the idea that this chapter has actually been walking toward all along. It is perfectly logical. It solves the mass problem, the food problem, the aging problem, the boredom problem, every problem we have met tonight, all at once. And the first time you truly picture it, it drops the temperature of the room. Stop sending grown people. Send the beginnings of people. A human embryo, frozen at a few days old, is a speck. It does not eat. It does not breathe. It does not age. And it does not get bored. And frozen embryo storage is not speculation. It is a routine Tuesday in fertility clinics on every continent, with healthy children already born from embryos that waited in the cold for 30 years. So run the numbers on a different kind of arc. No farms, no rivers, no town, a vessel the size of a bus instead of a city, carrying thousands of frozen human beginnings, tended by machines, coasting dark and silent across the centuries with nothing aboard that can die of old age. It could ride a smaller sail. It could take the slow road and lose nothing. Of every Starship concept in this entire night, the seed ship asks the least of physics. Look at what it asks of everything else. The ship arrives, finds its world, lands, and then the machines must do the one thing machines have never done: grow the crew. Artificial wombs. And this is no longer pure fiction. Researchers have kept premature lambs alive and growing for weeks inside fluid-filled bags. But a lamb finishing is not a person beginning. And after the wombs comes the part no laboratory has ever touched. The first generation opens its eyes on a world with no mothers in it. Robot arms to rock them. Recorded voices to soothe them. An artificial intelligence assigned to teach them language, love, table manners, and what a human being is. Working entirely from archives recorded by people 4 centuries dead. Every child in history who ever learned to be human learned it from another human. These children learn it from a library. What walks out of that nursery 20 years later will carry our complete genome and our recorded voices. And I genuinely cannot tell you whether it carries us. That is not rhetoric. It is the honest edge of the question. And you can feel the second of our 3 nested questions. The civilization question, straining under the weight. Because a civilization is not a genome. It is the handing of a self from one generation to the next. And the seed ship replaces the hand with a recording. So here is the strange place. Act 2 leaves us. To cross the distance alive, we keep amputating. First the trip becomes longer than a life. So we send the town and sacrifice the middle generations. Then the town is too heavy. So we send sleepers and sacrifice certainty about what wakes up. Then the sleepers are too fragile. So we send seeds and sacrifice the parents entirely. Every step is logical. Every step works better than the last. And every step carries less of us and more of merely ours. Follow this road to its end, and something with human DNA reaches the stars, while humanity, the living, continuous, remembering thing, stays home in the cradle. That is the bargain on the table as Act 2 closes. And I would end the night there, grim and honest, if the universe had not left a door, because it has everything we have suffered tonight, every century-long crossing, every generation spent in the corridor, every frozen sleeper and orphaned seed. All of it rests on one single assumption, so obvious that we never thought to say it out loud. The assumption that a year is a year. That time flows at one speed for everyone, the traveller and the homebody alike, and that a 400-year voyage must cost somebody 400 years. That assumption is false. Physically, measurably, provably false. Time is not a metronome shared by the universe. It is local, and it is flexible, and it bends in exactly the direction a starship needs. This is not speculation and not a loophole in some fringe theory. It is the tested bedrock of modern physics. And it was uncovered in 1905 by a 26-year-old clerk in a Swiss patent office. A young man this channel has met twice before on other nights, reviewing engineering diagrams by day and, in the evenings, quietly noticing that the universe keeps two kinds of books. What he found means this: the 400-year voyage does not have to take 400 years. Not for the crew. For the crew, if the ship is good enough, it can take 8. Bern, Switzerland, 1905. In the patent office on Speichergasse, a junior examiner, 3rd class, sits at a wooden desk reviewing applications for electrical devices. He is 26 years old. He has a wife, a baby son, a physics degree that earned him no academic job anywhere in Europe, and a habit his supervisor tolerates, of finishing the day's patents quickly and then turning to the small pages of his own calculations. We have met this man twice on this channel. He is the clerk who, in this same miraculous year, will explain the trembling of pollen grains and prove that atoms exist, and who will abolish the ether, and with it the very idea of absolute rest. But the paper that concerns our journey tonight is the one where Albert Einstein discovered that the universe does not have a master clock. Here is the heart of it, and you can hold it without a single equation. Einstein took one experimental fact deadly seriously: the fact that light always passes you at the same speed no matter how you are moving. And he followed it wherever it led. And it led somewhere no one wanted to go. If the speed of light refuses to change, then something else must give way. And that something is time itself. Two people moving differently through the universe will genuinely, physically disagree about how much time has passed. Not feel differently. Not measure sloppily. Their clocks, their heartbeats, their aging bodies actually run at different rates. The faster you travel through space, the slower your time flows compared to those you left behind. Motion is a tax on time, and the universe collects it from everyone. Always. Without exception. Your instinct right now is the correct human instinct. That cannot be true. Time is time. A minute in Tokyo is a minute in Toledo. So let me tell you about the day 2 American scientists put that instinct on an airplane. October 1971. A physicist named Joseph Hafele and an astronomer named Richard Keating walk into an airport with 4 atomic clocks, cesium beam instruments, the most accurate timekeepers of their era, machines that agree with each other to within a few billionths of a second, and they buy them seats, ordinary commercial tickets, on ordinary passenger flights, around the world. The clocks fly east through the usual indignities of air travel, the layovers, the meal service, belted into their seats like unusually punctual passengers, while their twin clocks sit home at the United States Naval Observatory in Washington. Then the travellers are set beside the homebodies, noce to noce, and everyone looks at the numbers. The flying clocks and the stationary clocks disagree. The clocks that flew came back younger, offset by a few tens of billionths of a second, and offset by almost exactly the amount Einstein's 66-year-old equations demanded. Gravity's effect and speed's effect both showing up in the ledger, right where the patent clerk said they would be. $50 a seat, give or take, to prove that time itself bends. The universe, it turns out, will demonstrate its deepest secret to anyone who buys a clock, a window seat, and that experiment was only polite confirmation, because nature runs a harsher version of it over your head all day long. High in the atmosphere, cosmic rays strike air molecules and create sprays of particles called muons, and muons are famously doomed. They decay, on average, in about 2/millionths of a second, and even at nearly the speed of light, 2/millionths of a second buys roughly a quarter mile of travel, born 30, 40 miles up. Essentially, none of them should survive the trip to the ground. They should be extinct long before they reach the treetops, and yet muon detectors at sea level click steadily. All day, every day, counting travellers that arithmetic says cannot exist. They arrive because they are fast, and because they are fast, their internal clocks run slow. In our frame, the muon's 2 microsecond lifespan stretches 10 times over, 20 times over, long enough to finish the fall. Several of them have passed through your body since you started this chapter. You have been getting hit by time travellers all night. Now, the muon story has a second half, and the second half is the gift. Because ride along with the muon for a moment. From the muon's own point of view, nothing about its clock is strange. Its 2 microseconds tick past normally. Its brief life feels exactly as brief as it should. So how does it reach the ground? From the muon's frame, the distance shrinks. The 40 miles of atmosphere contracts to a few hundred yards. And that is the revelation hiding inside Einstein's paper. The one that changes our entire night. Time dilation and distance contraction are two views of one fact. For a fast traveller, the journey itself gets shorter. Space in the direction of motion compresses like a squeezed accordion. Honestly, physically, measurably, the light year, that brutal unit that has beaten us for 9 chapters, is not the fixed iron length we assumed. It is the distance measured by someone standing still. The traveller measures less. The faster the traveller, the less the universe charges. And there is no posted bottom to the discount. Feel what this does to every wall we have hit tonight. The 400-year crossing that devoured 20 generations. 400 years as counted by Earth. The cruise clock is a different ledger. And with enough speed, the same crossing cost the crew 40 years. Or 4. Push closer to the speed of light and the numbers turn frankly absurd. A photon, riding at exactly light speed, experiences the crossing of the entire visible universe as instantaneous. Distance, for light, does not exist at all. Between that extreme and our crawling rockets lies a sliding scale, and somewhere on that scale, every destination in the sky, the galactic core, the far arms of the Milky Way, Andromeda itself, drops inside the budget of a single human lifetime. Read that again? Because it is the sentence Act 2 said was impossible. No place in the universe is too far for one person to reach alive. The mathematics does not forbid it. The mathematics, for once in this entire night, is on our side. So the question stops being whether the door exists. Einstein opened the door in 1905, and muons fly through it every second, and the toll booth takes atomic clocks in coach. The question is whether anything human-sized can actually drive through, or whether this is one more mail slot, Another starshot trick that works for a gram and dies at a passenger. Which brings me to the machine. There is a ship, never built but entirely legal under known physics. No warp fields, no wormholes, no exotic matter, that is designed to collect Einstein's gift with a crew aboard. Its secret is patience. It does not need violent speed off the line. It needs one gentle push, held without interruption, forever. And the strangest thing about the most ambitious vehicle physics has ever sketched is what it would feel like to ride. Not like a rocket, like a hallway in your house. Aboard this ship there is up and down. Things fall when you drop them. Coffee pours. It is called the one-gravity Starship. And on paper, it can take a living human being to the edge of everything. Tonight, you board it. I want you to actually do this with me, because this ship deserves better than a diagram. You come up through the boarding tube expecting a cockpit, and instead you find a hallway. It could be a hallway in a hospital or a decent hotel. There is carpet. There is a ceiling and a floor. And the floor means it. Because when the ship departs, gently, without any roar you can hear from inside, your feet stay planted and your stomach stays calm, and a coffee cup fills from a pot exactly the way it fills in your kitchen. On another night on this channel, we watched a flight attendant pour coffee at 500 miles per hour to prove that smooth motion is invisible. This ship is that trick. Perfected. It will accelerate every second of its voyage, and you will never feel anything but home. Here is the entire design philosophy, and it fits in one sentence. Push at one gravity, the exact acceleration of a falling apple on Earth, and simply never stop pushing. That is all. There is no genius trick of speed. No violent launch. One gentle, familiar push, held without interruption. And the push does two jobs at once. It is the engine, and it is the gravity. The floor presses your feet at precisely the force your body was tuned for in Chapter 3. So your bones keep their calcium, and your heart keeps its shape, and your eyes stay round. The medical catastrophe of weightlessness never happens. Because aboard this ship, nothing is ever weightless. The crew does not train like astronauts. They live like commuters. And now, watch what patience does. Because this is where the night turns. One gravity is small. It adds about 20 miles per hour to your speed every second, which sounds like a sluggish sports car, but it never lets up. Hour after hour. And there is no air out there to fight you, and no friction to pay. After one day, you are moving at almost 2 million miles per hour, faster than any object our species has ever built, and you are still in the shallow end. After 1 week, you have left every record in human history so far behind that Parker Solar Probe looks parked, and after roughly 1 year of this gentle, relentless push, 1 year of coffee and carpet and ordinary mornings, you are travelling at about 3/4 of the speed of light. Crazy. That is when Einstein's gift from last chapter stops being a lecture and starts being your itinerary. Because at these speeds, the ship crosses into the regime of the muon. Your clocks run slow compared to Earth's. The distance ahead of you contracts like a squeezed accordion. Every month you hold the burn. The universe gets smaller and your discount gets deeper. With no posted bottom, the ship flips around at the halfway point, tail forward, and spends the second half of the trip braking at the same steady one gravity, which pays the forgotten toll from Chapter 7, the stopping, automatically. As part of the ride, acceleration, gravity, deceleration, arrival, one push, held long enough, solves the body, the boredom, the braking, and the light year, all four at once. So let me read you the timetable. These numbers come straight out of the standard equations of relativity, the same mathematics the muons obey, and every one of them is the time that passes for you, aboard, by your own aging body and your own wall calendar. Proxima Centauri, the nearest star, the destination that cost Voyager 70,000 years and the generation ship 5 centuries. 3.5 years. One way. A single presidential term. You could leave with a newborn and arrive with a kindergartner. The centre of the Milky Way galaxy. 26,000 light-years away. The supermassive black hole and the crowded ancient core we visited on another night. About 20 years of ship time. A career. A young officer could sign on at 25 and stand looking into Sagittarius A star before her 45th birthday. And Andromeda, the neighbouring galaxy, the most distant object your naked eye can see, 2.5 million light-years out. A distance so obscene that on our basketball scale from Chapter 2, it stops meaning anything at all. Aboard the one gravity ship. The crossing to Andromeda takes about 28 years. Read that number again. 28 years. Bored at 30. And you step out under the light of another galaxy at 58. Younger than most airline pilots at retirement. A schoolteacher's pension plan is longer than the voyage between galaxies. And if nobody ever shuts the engine off, hold one gravity indefinitely. And the arithmetic says you could cross from here to the edge of the entire visible universe. Tens of billions of light years. Within roughly 45 years of ship time. One human lifetime. Comfortably. A person could be born on this ship and, before their hair turned grey, watch the last galaxies in existence slide past the windows. I told you at the start of the night that we would ask how far a single living human can travel. And here, finally, is an answer that touches everything. On paper. With no new physics. With nothing but Einstein's own equations and a floor that never stops pushing. The answer is anywhere. Anywhere at all. Now, I owe you the truth about this ship. And I'm going to give it to you straight. Because this channel does not sell dreams without receipts. The one gravity Starship is legal under physics and bankrupt under engineering. And the bankruptcy is spectacular. The trouble is the oldest villain of the night. The deaf schoolteacher's equation. And at relativistic speed, it stops being a tyrant and becomes something closer to a black hole for money. Holding one gravity for years means pouring out energy on a scale that embarrasses civilizations, even granting the perfect engine. The antimatter drive from Chapter 5, running at flawless textbook efficiency with zero waste. The fuel needed to push 1 ton of ship on the Andromeda run works out to thousands of tons of matter and antimatter. And the antimatter half of that shopping list exceeds what our species could manufacture in millions of years at current rates. Use any realistic engine instead of the perfect one, and the numbers grow teeth. Fusion, fission, anything that keeps most of its own exhaust. And the fuel mass for a one-gravity galaxy crossing swells past planets, past stars, past sensor. Engineers have floated escapes, scoops that harvest hydrogen from the interstellar fog and burn the road itself as you drive it. And for decades, that idea, the ramjet, was the great hope, until closer analysis suggested the scoop's own drag likely eats the thrust. A parachute, sold as a sail. Nothing on any drawing board tonight builds this ship. I want to be honest with you. Nothing on any drawing board this century comes close. So why did I take you aboard at all? Why pour the coffee and read the timetable for a vessel no one can build? Because of what the timetable proves. Follow the logic of the night. Act 1 told us the traveller was too fragile and the distance too vast. Act 2 told us the voyage outlasts any life. And we started amputating. The town, the sleepers, the seeds. Each ship carrying less of us than the last. Every one of those surrenders rested on a single assumption. That the years of the journey must be paid in the years of a human life. The one gravity ship, buildable or otherwise, takes that assumption out behind the mathematics and disposes of it. Time is not the wall. A living, laughing, coffee-drinking human being can, in principle, reach any star you can point at. And the only things standing in the way are energy and money. And energy and money are the kind of wall our species has spent 10,000 years learning to climb. Slowly, rudely, but we climb, which means the great barrier of the universe is not what everyone thinks it is. It is not the speed of light, and it is not the length of a life. It is something else. Something the timetable was hiding in plain sight while you and I admired it. Go back and look at those beautiful numbers one more time. Because every figure I read you had a phrase attached. Quiet as a footnote. Ship time. 28 years to Andromeda. Ship time. Your years. Your calendar. Your aging body. I never told you how many years pass on Earth. Let me finish the story of your voyage. The one you boarded a chapter ago. You deserve to see how it ends. 28 years have passed. By your calendar. By your body. By the grey now showing at your temples. The engine that pushed you through half the trip and braked you through the rest finally falls silent. And the silence is enormous. Outside the windows hangs Andromeda. No longer a smudge in an autumn sky, but a ceiling of light. A trillion suns in a slow, frozen swirl. And beneath you turns a planet no human eye has ever seen. You are 58 years old. You did it. You are the single living human being who stepped out under the light of another galaxy. The answer to the first and strictest of our three questions. Alive and intact and standing in the impossible. And because you are human, you do the most human thing there is. You decide to call home. You compose the message carefully. You describe the crossing, the years of carpet and coffee, the day the galaxy filled the forward windows. You mention your sister, and the street you grew up on, and you ask, the way every traveller in history has asked, what has changed since I left? You aim the transmitter back along the way you came, at a galaxy that from here is itself just a pale smudge, one bright grain in the dark, and you press send. The message departs at the speed of light, the fastest anything can ever move. It will arrive in 2.5 million years. And here is the part I've been carrying since chapter 10. The fine print I promised you. While your clocks ran slow and your 28 years unfolded, Earth's clocks ran at Earth's pace. And on Earth, the day you stepped out beneath Andromeda, roughly 2.5 million years had already passed. Your sister has been gone for 2.5 million years. The street you grew up on, the city around it, the language this video is spoken in, the nations, the alphabets. All of it lies deeper in your planet's past than the invention of fire. Because hold that number up against our own history and look through it. 2.5 million years ago on Earth, there were no humans. Our ancestors were small-handed creatures on an African plain just beginning to chip stones into tools. That is the width of the gulf between your calendar and homes. Whatever receives your message, if anything does, will be as far removed from the people who launched you as we are from the first animals that dared to sharpen a rock. Your voyage did not only cross space, it fell through time. One way, forever. And there is no engine, anywhere in physics, that flies back. This is the price on the ticket, and I want to be precise about what is being bought and sold, because it is the strangest transaction in the universe. Einstein's gift is real. The universe genuinely will let you go anywhere, and it never lied about that, but reread the contract. It sells passage through space, and it collects payment in time. Your time. Everyone's time. At an exchange rate that grows crueler with every mile per second, and the payment is non-refundable. Fly fast enough to make the journey short, and you make the homecoming impossible. The same trick that shrinks the light years erases the world that sent you. Every relativistic voyage is a one-way trip. And here is the truth. almost nobody says out loud. It is one way, even if you turn around. Fly home from Andromeda, and the trip costs you another 28 years, and costs Earth another 2.5 million. And the place you land will share nothing with the place you left but coordinates. You can always return to the planet. You can never return to the time. Home is not a location. Home is a location plus a moment. And the moment does not wait. We have met this idea before tonight. In a gentler costume, think back to Chapter 2, to the golden record bolted to Voyager's side. The thunder and the greetings and the heartbeat of a young woman in love. I asked you to remember it, and I told you it would mean something different by the end. Here is what it means. Everyone who made that record understood, even as the needle cut the grooves, that it was a message to a future they could not inhabit, that any hand that ever plays it will belong to no one they could know. The record was honest about what it was, a letter with no return address, mailed into deep time, from senders who would not be waiting for a reply. Now look again at the one-gravity Starship, the proudest machine in tonight's story, and see it plainly. It is the golden record with a person inside. Every crew that ever boards a relativistic ship becomes a living letter, sealed at the moment of departure, addressed to a future that has never heard of them. The traveller arrives, the sender is gone, and the traveller and the sender are the same person. So this is where Act 3 leaves us. And it is a strange, tender place to stand. The universe turned out to be more generous than we feared, and more expensive than we dreamed. Distance surrendered. The light years, the great villains of the first half of the night, lie broken on the floor of Chapter 11. A human being can cross a galaxy in one lifetime, and physics will hold the door. But the door swings one way. The travellers who go farthest must pay with everything behind them. Family, nation, language, era, species, every anchor a person has, traded for raw distance. And the more distance, the cleaner the erasure. How far can humans travel? Farther than anyone guessed. It turns out, the real question, the one Act 3 quietly hands to Act 4, is what is left of the human when they get there. Because think about who steps off these ships now. The generation ship delivers descendants shaped by 5 centuries in a can. Strangers to Earth in body and tongue. The seed ship delivers our genome raised by recordings. Humanity with the handoff missing. And now, even the perfect ship, the one gravity miracle that carries a real, living, no times, original person, delivers them into a time so distant that everything defining them has turned to sediment. 3 ships, 3 technologies, 1 pattern, and the pattern is the toll booth of the cosmos. Every road to the deep universe charges the same fare. It takes Earth away from you, 1 layer at a time, and the layers have names. First your ground, then your years, then your era, then, perhaps, your kind. And still, knowing all of it, you would go, wouldn't you? Some of you watching right now, if the boarding call came tomorrow, would trade every anchor for that window seat at Andromeda. I know, because I would think about it too. And that pull, that willingness in a soft, earth-grown creature to pay everything for distance, may be the most human thing this entire night has uncovered. So let us honour it with the truth. Let us follow the travellers all the way out, past every star we can name, and ask the final size of the prize, because everything we have surrendered tonight was surrendered for a map. The biggest map there is, the universe entire, trillions of galaxies deep, and at least the map was always out there waiting, patient and fixed, however terrible the fare. Except that while we spent this whole night learning to travel, the map has been doing something behind our backs. It is not patient, and it is not fixed, and it has never once waited for anyone. The map is moving, and it is moving away. I just told you the map is moving, and I promise we are walking to the edge of it before this night is over. But there is one debt of honesty left to pay first, and it has been quietly piling up for 5 chapters. We have now met every ship that physics will sign for, the town that sails for centuries, the ark of sleepers and seeds, the one gravity miracle that trades your era for your destination. Each of them, on paper, delivers something to the shore of another star. Tonight, before we go any farther out, I want to stand on that shore and watch the hatch actually open. 3 ships, 3 futures. One question: who, exactly, steps off? Here is the first door. It opens on a world that would kill you and me in a season. A planet scoured by the flare storms of a red dwarf sun. And the woman who steps out is not wearing the armour the mission planners of our century would have demanded. She does not need it. 400 years ago, in a laboratory on Earth, her ancestors signed consent forms, and the edits they agreed to are now written into every cell she owns. Some of this is not fiction, and I want you to know that, in 2016, researchers in Tokyo took a gene from the tardigrade, that absurd little animal that survives naked in the vacuum of space, and expressed its shielding protein in cultured human cells, and the damage those cells took from radiation dropped by almost half, in one experiment. In our decade, human cells borrowed armour from another species. Now give that beginning 4 centuries of refinement. Bones that ignore low gravity. Blood that repairs what cosmic rays break. A body retuned. Line by line. For the road and the destination. Because the old model, the one you are sitting in right now, it was tuned for a planet it no longer lives on. She is the solution to Chapter 3, the fragile Earth-built body, solved at the source. And when she has children on that world, and their children drift further from the original blueprint, generation by generation, the biologists in her colony will face a naming problem. Her ancestors were Homo sapiens. What is she? Here is the second door, and I have to be honest with you before it opens. Everything behind this door is speculation. There is no working version, no half-working version, and no agreed roadmap to one. But serious people spend serious careers on it, so it belongs in the night. The second door opens and nothing breathes. A machine steps out onto the surface of a world thousands of light years from Earth, and inside its core it carries a pattern, the complete scanned architecture of a human mind. A person who, 4 centuries ago, lay down in a facility on Earth and agreed to become information. Understand the temptation, because it is enormous. Every wall we have hit tonight, the radiation, the food, the aging, the boredom, the centuries. Every single one of them is a problem of keeping meat alive. A mind recorded as data needs no air and no gravity. Can be beamed at the speed of light in principle. You can wait out a 1,000,000-year crossing in dreamless pause. Can be backed up, copied, restored. Send minds instead of bodies, and the tyranny of the rocket equation nearly starves to death. Because your cargo weighs almost nothing. Now the honesty. The human brain carries over 80 billion neurons, wired through trillions of connections. And after decades of heroic work, science recently finished mapping the complete wiring of a fruit fly, which has about 140,000. That is the current scoreboard. And even granting the technology, granting the scan, granting the machine that wakes up warm and witty and certain it is you. Philosophy has been waiting at this door for 100 years, with one question it will not drop. Is that you? Continued. Or is that a perfect stranger who remembers your life, while you ended on Earth 4 centuries ago? Here is the third door. You have seen it before. It opens in a nursery, on a morning under an alien sun, and a machine with careful hands is holding a newborn girl. She is the seed ship's answer, the child from Chapter 9, and I bring her back because of the 3 travellers on this shore. She is the strangest, and it takes a second look to see why. The edited woman was changed before the journey. The uploaded mind was changed by it. This child is not changed at all. Her genome is fully, flawlessly human. Indistinguishable from a baby born in Ohio tonight. By every measure a laboratory can run. She is us, the genuine article, delivered intact across the light years. And she will learn the word mother from a recording of a woman who died before her embryo was even loaded. Everything in her is human. Everything around her is archive. She is our species with its living handoff missing. The letter delivered perfectly, with no one left who can read it aloud. 3 doors. And now stand back with me, because seen together they form a pattern that individually they hide. Every one of these travellers exists to solve a wall we hit earlier tonight. The edited woman solves the body. The uploaded mind solves the mass and the time. The archived child solves the lifespan. And every solution works by the same method. It takes the word human, the one sitting in our title, in the question we have been asking all night, and it shaves something off. A blueprint here, a body there, a childhood there. None of the shavings falsifies the mission. All of them change what the mission delivers. So let us take formal inventory of our 3 nested questions, because tonight is the night the ledger closes on 2 of them. Can a single living human make the journey and step out at the far end? After Act 2, I told you no. Act 3 amended the ruling. Yes. Aboard a 1 gravity ship we cannot yet dream of building, and only by trading away every person and place and era that made them who they are. Call it a yes so expensive it bankrupts the traveller. Can a civilization make the journey? It can send one. What arrives? After the centuries in the can, or the nursery of recordings, or the gene edits compounding down the generations, is related to us the way a river's mouth is related to its source. Something continuous flows the whole way. Whether the water at the end is the water that started, you and the comment section can fight about, which leaves the 3rd question, the widest hull of the ship, the humble one. Can anything that carries our story make the crossing? Anything at all that could stand on a far world and honestly say, I came from Earth. And there, at last, the answer holds, yes. The edited woman can say it. The uploaded mind can say it. The archived child. The golden record. The gram of laser-sailed silicon. Every one of them can say it truthfully. This is what survives the night's long series of surrenders. And I do not say it sadly. Something of us, something real, something that remembers, can in principle reach almost any shore in the sky. Almost. I used that word on purpose, and now I have to pay for it, because every promise in this chapter, every door and every traveller, came with the same unspoken guarantee. The one assumption so deep we have never once questioned it in 13 chapters, that the shore will be there, that the destinations, however distant, are at least fixed, sitting patiently in the dark, waiting for anyone with the nerve and the centuries to come, that the universe is a map, and a map holds still. It does not hold still. While we spent this night solving engines and bodies and lifetimes, the universe has been quietly moving the shores, taking them, by off the map entirely, not hiding them, removing them, permanently, at a rate you can calculate, in a process that has already claimed almost everything you can see through a telescope. To show you, I need you to come outside with me one more time. It is a clear autumn night, and there is something I want you to find with your naked eye. On a truly dark autumn night in the northern hemisphere, far from city lights, you can find it without a telescope. Low in the constellation Andromeda, there is a faint, stretched smudge of light, soft as a thumbprint on glass. We have stood under it before on this channel. It is the Andromeda Galaxy. 1,000,000,000,000 suns, the most distant thing human eyes can see unaided. And its light spent 2.5 million years crossing the dark to reach you tonight. On the night we searched for stillness, that smudge taught us about motion. Tonight it is our destination. Chapter 11's proudest timetable. 28 ship years away. But before any ship sails, a navigator asks the oldest question in seafaring. What is out there, between here and there? And the answer is the emptiest answer in all of nature. Nothing. Almost perfectly. Almost mathematically nothing. On a scale that redefines the word. I want you to feel the difference between two kinds of emptiness, because your entire picture of this voyage depends on it. Inside our galaxy, space is empty, the way the ocean is empty. No land in sight. But the water itself is alive. Stars lie scattered every few light years in our neighbourhood. Between them drift the brown dwarfs. The failed stars too small to ignite. And the rogue planets. Worlds without suns. Orphans wandering the dark. And some surveys suggest the orphans may outnumber the stars themselves. A ship crossing the Milky Way is never truly far from a port. There is always gravity to sling around, ice to mine, hydrogen fog to scoop, some island within reach of a damaged vessel. The galaxy is an archipelago, 100 billion harbours deep. Now sail off its edge. Between the Milky Way and Andromeda lies a gulf of 2.5 million light years, and that gulf contains, as far as our finest instruments can tell, close to nothing at all. A scattering of exiled stars, flung out by the violence we explored on other nights. So lonely that if you lived on a planet around one, your night sky would hold no stars, just blackness, and the faint-lit spirals of distant galaxies, entire islands visible from an ocean with no waves. The gas out there is thin to a whisper of a whisper, far emptier than the space between stars, which itself shamed the best vacuum chambers on Earth. No ports, no fuel, no ice, no slingshots, no second chances. A ship that suffers its one unlucky failure in the Gulf will coast, dead and perfect and cold, for longer than mammals have existed, and nothing will ever pass close enough to notice. Crossing a galaxy is sailing. Crossing between galaxies is stepping off the map of the world entirely, and trusting the ship, alone, for every second of a voyage through a place where the concept of rescue has no meaning. So the ocean between islands is the harshest road in nature. Understood. But tonight we have the one gravity ship, and its beautiful, unbuildable timetable does not care about ports. 28 ship years, harbour to harbour. And in fact, for this particular crossing, the universe adds a strange mercy. One we learned about on the night we discovered nothing stands still. Andromeda is coming to us. That smudge overhead is falling toward the Milky Way at 250,000 miles per hour. And in several billion years the two archipelagos will merge into one. The great combined galaxy, astronomers have already nicknamed Milkomeda. Our gulf is closing on its own, and Andromeda is only the largest neighbour. Around the two giants swarms a family. The Triangulum Galaxy and dozens upon dozens of dwarf galaxies. Some 80 islands large and small, all bound to each other by gravity. All orbiting a common centre like boats moored in one bay, spanning roughly 10 million light-years of ocean. Astronomers call this family the Local Group. Hold that name. It is about to become the most important name of the entire night. Because gravity is a promise. Every island in the Local Group is tied to every other. Permanently. And given ships and patience. Every single one of them is reachable. The whole bay is ours. In principle, forever. 10 million light years of territory, 80 harbours, 1,000,000,000,000 suns, and more on the way. So the question of the night, how far can humans travel, now comes down to one final step. The biggest step there is, past the bay, beyond the local group. The ocean opens onto the true deep, and the next great city of galaxies stands in plain view of your backyard telescope. The Virgo cluster, 2,000 galaxies, a metropolis of islands, glittering about 55 million light-years away. And by now you know better than to fear a big number, because the one gravity timetable eats big numbers for breakfast. Run the mathematics one more time. 55 million light-years, half accelerating, half braking. One gentle push held the whole way. The answer comes back just as smooth and just as absurd as ever. Roughly 40 years. Ship time. A working career. Bored at 25. Retire in Virgo. The mathematics smiles. The way it smiled at Proxima. The way it smiled at Andromeda. And it says yes. You can go. You can always go. And this time the mathematics is wrong. Not wrong in its arithmetic. The equations are flawless. And that is what makes this the strangest turn of the entire night. The ship performs perfectly. The engine never falters. The shielding holds. The crew stays young and healthy on their one gravity floor. Every promise of Chapter 11 kept to the letter. The ship is not the problem. The problem is the destination, because the timetable was computed on the map as it looks tonight. 55 million light-years. A fixed distance to a fixed city. And I told you at the end of Chapter 12 that the map is not fixed. While the ship sails, the ocean itself will be doing something no ocean on Earth has ever done. It will be growing. New water. Appearing out of nowhere. Everywhere. Between every island and every other island. Faster and faster. A rising tide of distance itself. The city of Virgo is not sitting in the dark waiting for us. It is receding, and the recession is accelerating. And past a certain line in the sky, and this is the sentence the whole night has been building toward. There are shores that no ship, no signal, no beam of light leaving Earth tonight can ever reach again. Not ever. Not with perfect engines. Not with infinite time. Astronomers found that line. They know why it exists. And they know, galaxy by galaxy, what has already crossed it. And the count will frighten you. It frightened them. The discovery arrived in 1998 from two rival teams who were both trying to measure something completely different, and who both got the same impossible answer, and who both, at first, assumed they had made a mistake. They had not made a mistake. The universe is running away, and it is time you saw the numbers. In the middle of the 1990s, two teams of astronomers set out, in open rivalry, to answer what sounded like a bookkeeping question. Everyone already knew the universe was expanding. We learned that on another night on this channel, the swelling raisin bread, the galaxies riding apart on stretching space, Edwin Hubble's great discovery of 1929, and everyone also knew, or thought they knew, what had to happen next. The universe is full of matter. Matter pulls on matter, so the expansion, launched by the Big Bang, must be slowing down. The way a ball thrown upward slows, dragged back by everything's gravity on everything else. The only question worth arguing about was the rate. How fast is the universe breaking? Is there enough matter to someday stop the expansion entirely and pull it all back in? Or does it coast outward forever, slowing but never quite stopping? Two teams, the Supernova Cosmology Project and the High Z Supernova Search Team, raced each other for years to measure that deceleration. It was one of the safest bets in physics. The universe slows down. Find the number. Collect the prize. Their measuring sticks were exploding stars. A particular kind of stellar detonation. A Type 1, a supernova, always erupts with almost exactly the same intrinsic brightness. A standard candle. The same 100-watt bulb everywhere in the cosmos. Spot one in a distant galaxy. Measure how faint it looks from here. And you know how far away it is. Honestly and directly. Do that for dozens of galaxies at every depth of the sky. Stack the distances against the speeds. And the universe's breaking history falls out of the data. Both teams did exactly this. For years. Checking and rechecking. Hunting their own errors the way careful people do. And in 1998, both teams, independently, glaring at each other across the field, published the same impossible result. The distant supernovae were too faint, fainter than any version of a slowing universe allowed. The explosions were farther away than they had any right to be, as if the space between us and them had stretched more than expected. Not less. The universe is not slowing down. It is speeding up. I want you to sit with how wrong that is. Throw a ball into the sky and it slows. Arts. Falls. That is gravity. The most dependable fact in the universe. What these teams found is a ball that leaves your hand, rise, and then accelerates, climbing faster every second, as if the sky itself had reached down and started pulling. The expansion of the universe, 14 billion years old, is not coasting and not breaking, somewhere around 5 or 6 billion years ago. Roughly when our sun was forming, the expansion quietly shifted into a higher gear, and it has been gaining speed ever since. Something is pushing, something soaked into every cubic inch of empty space, outmuscling the combined gravity of every galaxy in existence. Physicists named it dark energy, and I will tell you tonight what we told you on that other night. The name is a placeholder for our ignorance. What we can measure is the push. It is real. It fills everything. And by every accounting we can run, this dark push makes up most of the energy in the universe. The stars, the planets, you, me, everything that shines or breathes. All of it together is a minority stakeholder in reality. The majority owner is the push, and the push works for distance. Now, here is where tonight parts ways with that earlier night. Back then, expansion was a wonder to be understood. Tonight we are travellers, and for a traveller, an accelerating universe is not a wonder. It is a closing door. Watch what acceleration does to a voyage. Remember the rule of expansion, the raisin bread rule. The farther away a galaxy is, the more stretching dough lies between you and it, so the faster it recedes. Double the distance, double the speed of retreat, which means that for any traveller, there is a distance where the arithmetic turns fatal, a distance where the space between you and your destination is growing by more than a light year every year. Aim at a shore past that line and something obscene happens. You sail at the speed of light, the absolute limit, the fastest the universe permits anything to move, and the harbour gets farther away, every year of flawless. Maximum speed sailing leaves you facing more ocean than the year before. On the night we discovered the universe was expanding, I gave you the image, and I am giving it to you again. Because tonight, it is no longer a metaphor about light. It is a forecast about our ships. A swimmer, stroking perfectly, toward a shore that recedes faster than anyone can swim. The swimmer never tires and never stops. The shore simply never comes. And you might reasonably object. Wait. The speed of light is supposed to be the law. Nothing outruns light. How can a galaxy recede faster than light without breaking the universe? We answered this on that earlier night, and it is worth 30 seconds tonight. because the entire ending of our journey turns on it. The cosmic speed limit applies to things moving through space. A ship through the void, a photon through the dark. Those can never pass light speed, and never will. But the galaxies beyond that line are not moving through space. They are sitting nearly still in their own neighbourhoods, exactly as we are, while the space between us grows. And the growth of space was never issued a speed limit. Add up enough stretching ocean and the total can exceed any speed you like. No law broken. No permission needed. Which is precisely what makes it so lethal to a traveller. You cannot outrun it. Because it is not running. It is not motion at all. It is the road itself, lengthening beneath you faster than your wheels can turn. And no engine ever built or ever imagined turns wheels against that. So the accelerating universe draws a line in the sky, a radius around us, a last shore, inside which every harbour can still, in principle, be reached, and beyond which every harbour is already gone, unreachable forever, by anything, at any speed, ever. Astronomers have computed that line, and it has a name, the Cosmic Event Horizon. And tonight, for a traveller leaving Earth, it stands roughly 16 to 17 billion light-years out. That is the true edge of the map, not the edge of the universe. The universe almost certainly continues far beyond it, perhaps without end. It is the edge of the possible, the property line of everything any child of Earth can ever touch. 17 billion light-years. And I know what that number feels like. It feels like a reprieve. After a night of walls, here is a wall, so far away it reads like no wall at all. A fence at the far end of forever. The visible universe. The great sphere of everything our telescopes can see. Stretches 46 billion light-years in every direction, packed with something like 2 trillion galaxies. Surely most of that royal estate sits safely inside a 17 billion light-year fence. Surely the door is still mostly open. I have run the numbers, and others far more careful than I have run them properly. And I have to tell you what they say. Of all the galaxies in the visible universe, all 2 trillion islands of stars you could point a telescope at tonight, the fraction that remains inside the fence, the fraction a ship or a signal leaving Earth right now could still ever reach, is about 6%. 6%. The other 94% of everything you can see is already on the far side of the line. Already gone. Not going. Gone. In the only sense that will ever matter to a traveller. While you and I spent tonight learning to build the ship. And it gets 1 degree stranger. And 1 degree more urgent. Because that 6% is not a settled number. The line is still moving. The door is still closing. Tonight, this hour, at a rate astronomers can calculate, and in the next chapter I am going to tell you what that rate is, and what it means for how much universe your grandchildren's grandchildren will inherit. I will warn you now, of everything in this entire night, it is the fact I find hardest to hold. The universe is leaving, and it does not wait for boarding. Let me show you what 6% actually means. Because a percentage is easy to hear and hard to feel. Go back to the dark bedroom where this channel has begun so many of its nights. You are lying there, and the whole visible universe is spread above you like a ceiling, 2 trillion galaxies deep. Now imagine every galaxy you can still actually reach begins to glow green, and every galaxy already beyond the line glows red. You are expecting a ceiling stained with warnings. A red patch here, a red region there. That is not what you would see. You would see a ceiling of red. Red, from horizon to horizon. Red at every depth. Red past counting. An entire sky of shores already lost, with 1 modest green bubble around you, huddled close, 6 galaxies in every 100. 19 out of every 20 galaxies in the night sky are, for every practical purpose of travel, for every ship and every signal and every ambition our species will ever launch, already gone. The Hubble Space Telescope's deep field images, those famous photographs crowded with thousands of golden islands, are, by the numbers, almost entirely photographs of places no one from Earth will ever go. Not hard places, not distant places, impossible places, sealed off by the geometry of the universe itself. And here is the detail that bends the mind further. We can still see them. We will see them for ages yet. Their light is still arriving, and their light will keep arriving, because the photons already in transit, already deep in the crossing when the door closed behind them, will keep completing their journeys for billions of years. Understand what that makes of the deep night sky. It is an album of photographs from places that are gone. Every one of those red galaxies overhead is showing you its past, faithfully delivered, while its present has already slipped over the horizon, where nothing from here can ever follow. On the night we search for stillness, I told you the universe visible from Earth is mostly made of goodbyes, and back then it was a poetic way to describe old light. Tonight the sentence collects its full meaning. They are goodbyes in the literal sense, farewell notes, still being delivered, from shores that have already left. Now, the door is still closing, and I promised you the rate. Here it is. The expansion accelerates. The horizon holds its ground, and one by one, galaxies at the very edge of the reachable 6% drift across the line, out of our forever, permanently. Astronomers can compute the traffic across that boundary, and averaged out, it comes to tens of thousands of galaxies crossing per year, which means something arithmetic will not let us look away from. In the 90 or so minutes you have spent with me tonight, while we boarded ships and poured coffee at one gravity and learned to bend time itself, on the order of a few thousand galaxies, each one an island of billions of suns, each one carrying whatever worlds and weather and possibly watchers it carries, slid across the cosmic event horizon and left the reachable universe forever. It happened while I was explaining the rocket equation. It is happening now, in complete silence, with no flash and no sound. The keenest catastrophe in existence. Nothing anywhere marks the moment a galaxy becomes unreachable. The universe does not keep a bell for it. I want to be honest with you, the way this channel has always tried to be honest. Because a fact like this invites panic, and the truth is stranger than panic. This is a deadline, but it is a deadline of billions of years. No one needs to pack tonight. The galaxies crossing the line this evening were already 40 billion light years away. Shores no ship of ours was ever seriously going to chase. The 6% will erode with cosmic patience, over spans that make the age of the Earth look like a weekend. And yet I cannot call it harmless, because it is the only deadline in existence that can never be extended. Every other deadline our species has ever faced could be argued with, appealed, engineered around, pushed. This one is written into the geometry of space-time by an acceleration nothing we know of can touch. The universe does not do extensions. Each year, the estate that any civilization in our position could ever inherit gets smaller, and it will never once get larger again. We are watching the greatest opportunity in history expire in the slowest possible motion. And the expiration began before we were born, before the Earth was born, and no one on this planet was ever asked. So face the ledger of the night one last time, because our third question, the humble one, the last hull of the ship, is now on the table. Can anything that carries our story reach the far universe? Anything at all. And notice what is answering this time. Not biology. We solved biology. We edited it. We uploaded it. We archived it in chapter 13. Not engineering. We granted ourselves the perfect engine in Chapter 11, and it changed nothing about this wall. Not time. We have relativistic ships that laugh at time, and machine minds that can pause for 1,000,000 years. And none of it matters here, because this wall does not tax speed or lifespan or patience. Send the hardiest thing conceivable, a diamond probe, an immortal machine bearing the whole library of Earth. Launch it tonight at 99.99% of light speed and let it sail for 1,000,000,000,000 years, aimed at the red ceiling. At the 94%, it arrives nowhere. The ocean grows faster than any hull can cross it. For the first time tonight, all three of our nested questions receive the same answer at the same wall. Not the person, not the civilization, not the story, past the horizon. Nothing of Earth can ever go. This is the final property line of the human species, and of every species, and it was drawn by no one, for no reason we understand, by an acceleration we cannot explain. Name it though we did, and a thought may be arriving for you right now, the same thought that has occurred to every person who ever truly absorbed this. If we are fenced in, then so is everyone. The fence is not around Earth. It is around every point in an accelerating universe. A horizon for every observer. A bubble for every civilization that has ever looked up. Whatever minds exist out there in the red. Tonight some of them may be pointing their instruments at our patch of sky. At a slide of ancient light containing the Milky Way. Knowing they can see us and never, ever reach us. The universe may be full of neighbours in the deepest sense. All of us visible to each other. All of us sealed from each other. An ocean of islands where every boat in existence is too slow for the tide. Not through anyone's failure, but by the shape of the water itself. I find that thought lonelier than an empty universe. And stranger, and somehow more tender. All those lights in the sky, all of them waving. None of them coming. So there it stands. The true answer to the question in our title. And it has a shape nobody expected when we set out tonight. How far can humans travel in the universe? Not to the edge of what we can see, to the edge of a bubble, roughly 17 billion light years deep, holding 6 galaxies of every 100 in the sky, and shrinking, forever, by tens of thousands of islands a year. Unless you have been patient all night, and you know this channel keeps its promises. So let us finally say the words out loud. Warp drive, wormholes, the doors in the back of the universe, the ones science fiction has trusted for a century, the ones that do not outrun the tide, but duck beneath it entirely. We devoted a whole night on this channel to the strange discovery that one of them is, mathematically, legal. Tonight, with the fence at last in view and everything at stake finally clear, it is time to ask the only version of the question that matters. Did the universe leave a key under the mat? Or is the 6% truly the end of the story? In 1994, a young Mexican physicist named Miguel Alcubierre was working on his doctorate at the University of Wales, spending his days on the mathematics of general relativity and his evenings, by his own cheerful admission, watching Star Trek, and somewhere in that unlikely combination, he asked a question no one had ever asked in quite this way. Every physicist on Earth knew that faster-than-light travel was forbidden, but Alcubierre noticed the fine print in the law. The prohibition applies to things moving through space. So he turned the question around. Forget the ship. Ask the equations of Einstein directly. Is there a shape of space-time itself? Some configuration of the fabric that could carry a passenger across the galaxy faster than light, without the passenger ever moving through space at all. He worked out the geometry, and the answer that came back out of Einstein's own equations was yes. Here is the design, and after tonight, you already own every idea inside it. Take a bubble of ordinary, flat, well-behaved space, with a ship floating peacefully at its center. Now contract the space in front of the bubble and expand the space behind it. The bubble slides forward, carried by the moving fabric, like a surfer carried by a wave, and there is no speed limit on how fast it can slide. Because remember the loophole we met 2 chapters ago, the one the distant galaxies exploit every single night. Space itself was never issued a speed limit. The expanding universe already moves entire galaxies apart faster than light. Legally, effortlessly, without breaking a single law of physics. Alcubierre's insight was that the loophole has no clause restricting it to nature. If space can stretch on its own, then in principle space can be stretched on purpose, and a civilization that learned to do it could ride the fabric anywhere. Inside the bubble, the crew feels nothing. No acceleration, no time dilation, no 28 years to Andromeda, no 2.5 million year goodbye. The clocks aboard stay in step with the clocks at home. You could take the warp bubble to another galaxy and return for dinner, and your sister would still be there. And this is not a fantasy author's rulebook. This is a solution, published and peer-reviewed, of the same equations that run the GPS satellites over your head. We gave that discovery an entire night on this channel. So tonight, I will go straight to the question that matters at the end of this particular journey. What does the key cost? Because the equations, as they always do, present a bill, and the bill is where the dream meets the universe we actually live in. To curve space in the way the bubble requires, you need something no one has ever held. Ordinary matter, everything you have ever touched, curves space one way. It attracts. The warp bubble demands the opposite. A substance with negative energy. Exotic matter. Stuff that repels. Stuff that in some meaningful sense weighs less than nothing. And before you dismiss it, here is the twist that keeps this idea breathing. Negative energy is real. In the 1940s, the Dutch physicist Hendrik Casimir predicted that 2 uncharged metal plates, held a hair's width apart in a vacuum, would be pushed together by the vacuum itself, because the empty space between them is emptier than empty, a sliver of genuine negative energy. Decades later, the effect was measured in laboratories, and it is exactly as strange as it sounds. The universe does permit negative energy. It writes small checks of it, in gaps thinner than a human hair. Now, compare the check to the bill. Alcubierre's original bubble required negative energy on a scale larger than the total energy of the observable universe, which is the mathematics gently laughing at you. Clever refinements over the years, reshaping the bubble, thinning its walls, have hauled the price down enormously, to something like the mass energy of a planet, or by some optimistic accounts less. Converted entirely into a form of matter we have only ever produced in whispers between metal plates. The gap between what the universe has demonstrated and what the ship requires is not a gap of engineering. It is some 30 orders of magnitude of physics we do not possess. And beyond the price tag stand quieter problems. Questions of whether the bubble can be steered, or stopped, or whether the crossing itself builds up a wall of radiation at the bubble's leading edge that arrives at the destination like a weapon. The honest status is this. The warp drive is legal on paper, unpaid in practice, and nobody knows if the universe accepts this currency at all. And the warp bubble has a cousin, older and stranger. The wormhole. Instead of riding the fabric, I'll fold it, take the sheet of space-time, bend it back on itself, and punch a tunnel from here directly to there. So the journey of millions of light years becomes a single step through a doorway. These are also honest solutions of Einstein's equations. Studied seriously since the physicist Kip Thorne and his colleagues worked out in the 1980s what a traversable wormhole would require. It requires the same impossible groceries, exotic matter, negative energy, this time woven into the throat of the tunnel to hold it open. Because an unsupported wormhole slams shut faster than light can cross it, a doorway that is also a trap. And wormholes carry one extra shadow the warp bubble mostly avoids. Connect two distant points of space, and, with a little orbital mischief, you can connect two different times, and the universe begins to flirt with paradox, with effects preceding causes. With all the machinery of reality creaking, some physicists suspect, and Stephen Hawking half joked in a famous conjecture, that the deep laws conspire to slam every such door before a time traveller can use it, keeping history safe for historians. So here is where the keys sit tonight. Stated as plainly as I can, the mathematics says the doors exist. The Casimir effect says the strange fuel exists. In truss, in slivers, between plates in a laboratory, and between those two truths yawns a canyon that a century of physics has not crossed, and may never cross, because it is entirely possible that the universe permits these solutions on paper the way a bank permits you to write a check for $1 trillion. The check is legal. The account is empty. No observation anywhere in the sky has ever shown us a warp bubble or a wormhole in the wild. If the universe builds them, it is keeping them somewhere we have not looked. And yet I will not close this door with a sneer, because this channel has stood inside too many impossibilities that came true. The experts of 1890 knew heavier than air flight was a fool's errand. And they had mathematics too. I want to be honest in both directions at once. And honesty in both directions sounds like this. Nothing we know forbids these machines absolutely. And nothing we know builds them. And the fence around the 6% stands tonight exactly where Chapter 16 left it. But if some century far downstream of ours learns to write in negative energy the way we write in steel, then everything I told you last chapter gets torn up. The horizon stops being a wall. The red ceiling turns green. And some video on this channel becomes gloriously, wonderfully wrong. I genuinely hope it happens. It would be the happiest retraction in the history of science. Until then, we plan with the universe we can prove, and that means the time has come. No more ships to board. No more doors to try. 14 billion years of cosmic history. 17 chapters. 3 nested questions. And one night of your time have all funneled down to a single unanswered thing. The question we packed at the very beginning, in a freezing capsule behind the moon in April of 1970. How far can humans travel in the universe? It is time to answer it. All of it. And then I owe you a number. And a promise I made you in Chapter 1. 1.5 light seconds. Bring it with you. We are going home the long way. Come back with me to where the night began. April 1970. The far side of the moon. The cabin of Apollo 13 is dark and cold enough to see your breath. The instruments are powered down to whispers, and 3 men are riding a broken ship around the back of another world, farther from home than any human beings have ever been, not knowing if the machine wrapped around them will hold together long enough to carry them back. And I told you in Chapter 1 that I was holding back a detail from that moment, saving it for the end, because it would mean more once you had seen the whole map. Here it is. As the moon rolled by beneath them, grey and cratered and lit like nothing on earth, 2 of the 3 men, Jack Swigert and Fred Hayes, let go of the checklists, drifted to the windows, and started taking photographs. Dozens of them. They hung there in the freezing dark, in the middle of the most famous survival crisis in the history of spaceflight, filling film magazines with pictures of a landscape sliding past their window. And Jim Lovell, the commander, the man responsible for getting them home alive. I watched his crew photographing scenery in a dying ship and reminded them, with the timing of a man who had earned the right, that if they did not get home, those pictures would never be developed. They kept shooting anyway. Hold that image. 2 freezing men at the windows of a broken ship, spending irreplaceable minutes on wonder. Because that, as much as any equation tonight, is the answer to our question. But you came for the full accounting, and after 17 chapters, you have earned it. How far can humans travel in the universe? The honest answer comes in 4 layers. So here they are, un by un, the whole night in 4 breaths. Layer 1, with the bodies we were born in and the machines we can actually build, the answer is the neighbourhood, the moon, which we have touched, Mars, which we can reach if we choose to spend the treasure and accept the radiation. Perhaps, someday, the moons of the giant planets. The solar system is the property our species can walk on with the keys already in our pocket. And even that, as Chapter 3 taught us, will cost our bodies dearly. Layer 2, with physics we already trust and engineering we can honestly foresee. Our machines go to the stars and our species follows in pieces. Gram-scale probes on beams of light, reaching Proxima within a lifetime. And for human beings, the amputation ships of Act 2, the sailing towns that spend 20 generations, the arcs of sleepers and frozen seeds, something of us arrives at the near stars. Whether it is us, you and the comment section can settle. Layer 3, with the full permission of Einstein, no new physics required. Only energy on a scale we cannot yet touch. A single living human being can go essentially anywhere. One gravity, held without mercy. And the galaxy is a career. Andromeda is 28 years. The deep universe is 1 lifetime. The mathematics signs it. The price is written in the margin. And the price is everything. Your era, your people, your world, traded for distance. One way, no refunds, the golden record with a person inside. And Layer 4, the whole universe. No, not now, not ever, not for us, not for anyone. 94% of everything the telescopes show us has already slipped over a horizon that no ship, no signal, no desperate perfect engine can cross. And the estate shrinks by tens of thousands of galaxies a year. The universe at large was never on the table. We spent the night discovering that the question in our title has a ceiling, and the ceiling is made of space-time itself. Now, if the night ended there, it would end in morning, and it should not, because the morning misses the point so completely that it gets the story backward. So let me do the arithmetic nobody does. 6% survives inside the fence. 6% of 2 trillion galaxies. That is roughly 100 billion galaxies that remain. Tonight, genuinely reachable by something launched from Earth. 100 billion. Set that against the deepest measure of us there is. Demographers estimate that about 110 billion human beings have ever lived. Every person in every century since the species began. The reachable universe holds nearly 1 galaxy, an entire island of hundreds of billions of suns. For every human being who has ever drawn breath, that is what we are calling a locked room. And inside that room sits something better. The Bay, from Chapter 14. The local group. Our galaxy. Andromeda. Triangulum. And their 80 companions. 10 million light-years of harbours, bound to each other by gravity itself. And here is the quiet miracle I saved for last. Gravity beats the tide, the expansion of space, the force that steals the distant universe, cannot pry apart what gravity has already bound, when the far galaxies have all slipped over the horizon. In that unimaginably distant age, the local group will still be here, merged and calm and shining, 1 trillion suns burning for trillions of years to come, longer than the universe has yet existed by 100 times. The door to almost everything is closing. The home bay is ours forever. No horizon will ever take it. So take out the number I asked you to carry all night. 1.5 light seconds. the farthest any member of our species has ever been from home. Set by accident. By 3 cold men who photographed the scenery on the way. Now lay that number against the map we drew tonight. The bay that can never be taken from us runs 10 million light-years deep. The room beyond it, 17 billion. Every empire, every migration, every war and cathedral and love story in the whole human record has unfolded inside 1.5 light seconds. And the smallest territory the universe has permanently deeded to us is larger than that by a factor so vast the comparison stops being a number and becomes a kind of silence. We have not been fenced in. We have barely stepped off the welcome mat of a mansion we have not begun to walk. On another night on this channel, standing under the ancient light of the early universe, I told you that we live in the brief, privileged morning of the cosmos, the young hour when the evidence of the beginning is still in the sky. Tonight, at the end of this journey, I can add the second half of that sentence. The morning is also when the doors are open. Never again will the reachable universe be as large as it is right now. Every civilization that rises after us, here or anywhere, inherits a smaller room than ours. We happen to be awake in the widest hour there will ever be, on the porch, with the horizon at high tide, and 1.5 light seconds behind us. Nobody needs to pack tonight. The door takes billions of years to swing, but I keep thinking about those 2 men at the windows of Apollo 13, freezing, in real danger, half certain the pictures would never be developed. Shooting anyway. A species that behaves like that in a broken ship 1 light second from home. I do not believe that species stays on the porch. Not forever. The reflex that filled those film magazines is the same reflex that will someday fill a sail. So let the night sky settle over you tonight the way it always has. The red ceiling of farewells, still glowing. The green bay, waiting, somewhere out past Neptune. A golden record is sailing through the dark with the sound of surf and a young woman's heartbeat. Our first letter, already mailed. You have never been more than 1.5 light seconds from home, and the universe is still holding the door. Good night.